Hello and welcome back once again to my channel. Amidst the ongoing series on statistics, suddenly I switch over to something very different, of course, of my own interest, and that is beauty of mathematics, particularly solving a puzzle. So, as you see on the screen, this is a viral, you can say, a viral puzzle in the digital world, and it simply tells, if you translate into English, then it tells that 32 numbers 1 through 32, each being used once and once only, are arranged in such a cyclic way that sum of any two neighboring numbers is a perfect square, a square number. Say for example 4 plus 32 is 36 and so on, 6 plus 3 is 9 and so on. So this is the puzzle and solution is already on the screen, but my question is it a unique solution? Well, to answer this question there are two options. Either it's not an unique solution, right? So there may be some other solutions and you can try on a trial and error basis, and possibly uh, you will end up with a failure. So the other option is that it's a unique solution. So for that you have to establish logically that yes, it is a unique solution. Now how we can do that? Probably we can start with the uh, smallest possible number, that is two numbers, for example a and b, right? And a and b have to be unique in the sense that a can only be linked with b and b can only be linked with a. If it is so, then they are unique pair. Now you can think of another number c, which uniquely in the same way uniquely can be combined with b, and thus we get from AB a doublet to ABC a triplet. And suppose you have similarly got another triplet DEF. Now if you want to increase the chain length, then what you can do? You can try to link A and F, but again with the same condition that A and F sum must be square. Not only that, A and F are unique in the way I have explained just now. Now let us inspect that how many squares are possible with our numbers 1 through 32. And as we see that there are 6 such squares: 4, 9, 16, 25, 36 and 49. If you take the next one, that is 64 and onwards, you will see that it requires number greater than 32, but we are limited by 32. So now let us check one by one what are the possible pairs that form that square number 4, 9, 16, etc. So let us examine. For 4 we have only one option, 1, 3, because the next one is 2, 2. For 9 we can have 1, 8, 2, 7, 3, 6, 4, 5, and then 1, 2, 3, 4, 5, 4, and that is nothing but the 4, 5. So we stop here and we get only 4 such pairs for square number 9. Similarly we can see for 16, you can see for 25, 36 and 49. So this includes all possible pairs to form the squares 4, 9, 16, 25, 36 and 49. Okay. Now interestingly there are 8 numbers which are in 2 columns only. I repeat, 2 columns only of 36 and 49, and those are, you see, 25 through 32. Here also you see 25 through 32. So these numbers are only in these 2 columns and nowhere else, right? And thus we claim that we can get 8 unique triplets like PQR. Why? For example, suppose the first triplet 4, 32, 17. So 32 is here and here, and 32 can be linked either with 17 or with 4. So naturally, keeping 32 in the middle, we can have only 4 and 17. So thus we call it a unique triplet, right? So similarly for 31 onwards, for 31, 30, 29 and so on, we get the triplets T2 to T8, right? Say another example, 25 and 24, and 25 is here with 11. So 11, 25, 24, this is a triplet, valid unique triplet, right? So next, is there any other such number which occurs in 2 columns only? If you inspect the other columns, then you will see yes, 13 is such number, because here 12 and 13 and here 3 and 13 is nowhere else, right? So 13 is another number in column 16 and column 25. So naturally we get another triplet 3, 13, 12, right? So we get the ninth triplet 3, 13, 12, and obviously we can call them unique the way I have defined uniqueness, right? Well, so thus we have already used, we have already collected the valid numbers which are used in our triplet forming, and they are 3, 13, 12 and 25 through 32 and 4 through 11, right? So now focus on something else. There is a condition, natural condition, that each number 1 through 32 is to be used once only. So we can strike out all pairs in any column if the pair contains the numbers that we have already used, right? So it will be clear from the example, and we will strike out by this cross in different columns. So what are those pairs? So for example, in the first column 3, 1, 3, will strike out this possibility because 3 is already in 3, 13. Okay, so this for example, and by same logic we can strike out the rest of the pairs in other columns as well. So you can check it on your own. So the stock we have taken out some of the numbers, some of the pairs. So the question is what we are left with and what we have used. So far we have used, you see, 3 and then 4 to 11, then 12, 13 and then 25 to 32. So 3 to 13, 11 numbers, 17 to 24, 17 to 24 here because 32 is connected with 17. So 17 is already taken. So 17 we have already taken, and we have to strike out from anywhere else. Say for example here 17 was there, so it is not valid, acceptable. So we have taken 9 triplets, that is 3 into 9, 27 numbers in 9 triplets, and those numbers are 3 through 13, 17 through 24 and 25 through 32. That is 11 plus 8 plus 8 numbers, and we are left with only 5 numbers, and they are marked with yellow color. So 1 and 15, 2 and 14 and 16, not 9 because 9 is here we have used. So we are left with 1, 15, 2, 14 and 16, right? So this is the situation where we end up till now. What next? To search for unique sextet. So we have got the unique possible 9 triplets. Now we have to join these triplets again uniquely to get 3 plus 3, 6, that is a group of 6 numbers, that means sextet. So the combination would be like some ith triplet plus jth triplet equal to some sextet. Okay, so let us examine. So we have jotted down here all the 9 triplets, and the triplet structure in general is PQR, and then our search is how to do that search. The n numbers, the P and R, say Pi and Ri, this would be I, of ith triplet to be combined with Pj and Rj, the n numbers of jth triplet, Tj, right? But uniquely. So this is uniquely. How? By inspection we can go ahead. Say for example, if we take T5, so 8, 28, 21, and then if you inspect this 21 can be combined to which numbers with n numbers, this n numbers, a list of n numbers are there, and then you can find interestingly that 21 has the only option to be linked with 4 of T1. That means this 4, 32, 17. So there is no other way that 21 can be combined with anything else other than 4. So that means we are going to combine T1 and T5. So T1 and T5, that gives you the first sextet, and that is 17, 32, 4, 21, 28, 8. So from here we get from T5 21, 28, 8, 21, 28, 8, and 8, 4 is combined to 21. So I have reversed the order only of T1. So 4, 32, 17, 4, 32, 17. So we have got the first sextet. Similarly, just by inspection, you are in search of unique combination, right? So by inspection, we can find that the T8, 11, 25, and 24. This 24 has the only option to be linked with 12 of T9. So here T9. So we have to combine T8 and T9, T8 and T9 to get the second sextet S2, and we get minus 11, 25, 24, then 12, 13, 3. So 12, 13, 3. So that is the second sextet. Can you find any more? Let us try by inspection. So T2, focus on T2, 5, 31, 18, and again you will see that there are so many numbers, n numbers of the chain, small chains, triplets, that 18 has the only option to be linked with 7 of T4. T4 is here. So 7, 29, 20. So naturally we combine T2 and T4 and to get the third sextet. So 5, 31, 18 from here. 531 from T2, 531, 18, and then T4, 7, 29, 20, 7, 29, 20. So this is your third sextet, and of course unique. Now we are left with we are left with what and what? Yeah. So we are left with T3 and T7, for example, because you can be you might be tempted to combine 10 and 16 because they give a perfect square 16. So we can try with T3 and T7 to get 19, 36, and then 10, 26, 23. So 10 and 6 are combined. But here is an interrogative sign. May we do that? Probably no, because 6 and 10 that you are combining is not the only or unique option like the earlier cases S1, S2 and S3, and it's valid for both 6 and 10, as now you can think of combination not only between triplets but triplets and sextet combination is also open now. So you have to keep in mind all the S1, S2, S3 you have got so far uniquely, and then you see that 6, 3 and 6, 10 both options are possible. 6, 3 is coming from S2 here. S2 we have already got, and 3 is one of the n numbers. And similarly 6, 10, but 10, 15 is also possible, and 15 is still left with us freely. Okay, so we see that this is not the unique combination, this T3 and T7 combination. So what to do then? To go for trial and error, or is better to look for other possible unique combinations. Other means the numbers or the chains that we are left with, and you see that we are left with, if you carefully see that we are left with S1, S2, S3 that we have already made, and T3, T6, T7, the 3 triplets, and of course the 2 pairs 1, 15, 2, 14 and 16, the sole single number. So we are now looking instead of going for it these two possibilities and going extending the chains and might be ending up with a failure, rather we can go for other unique combination search from the given left out numbers. Okay, so let us try. So I have listed again this. We are left with S1, S2, S3 with this n numbers, and T3, T6, T7, 115, 214 and 16, right? Now look at T6, 9. So if you search, then interestingly you will find that 9 can be linked to 16 only. 16 only, this sole number 16, and no other numbers 2, 14, 1, 15, whatever, or the n numbers 10, 23, 6, 19 and so on. It is the only option that 9 can be linked with 16. So we are taking T6 from here, 9, 27, 22, and we are adding 16 to this series. Okay, but in turn you can again check that the 16, the n number so far of this chain, can be linked with 20 only of S3. S3 means here it ends with 20. So that means you have to combine S3 and the chain 16, 9, 27, 22. So these two have to be combined. 20 and 60 will be the combining link. So we have to join 5, 31, 18, 7, 29, 20, and then this one 16, 9, 27, 22. 16, 9, 27, 22. Clear? So far we have got a unique chain of this length. Now again we focus on the one of the n numbers 5 of this series, and again you will see that 5 can only be linked with 11 of S2, 11 and nothing else. So you can call that the next combination is also going to be unique. You are now combining S2, that is 11, 25 up to 3, and then 5, 31, 18, 7, this long series, right, to be joined. How? Here you get 3 is again at the one end, and 5 here, 5 and here 11. So 11 and 5 are colored, so they are joined to give you a longer series and unique series, right? So far so good. Now what we are left with, we have already used in this slide S2 and S3. So we are left with S1 and T3 and T7. T6 and T6 we have used here, and so we are left with S1, T3, T7 and these numbers 1 and 15 and 2 and 14. 16 is already used. Okay. So again I have listed this is the long series 16 in numbers, the chain length 16, and naturally 32 minus 16, that is we are left with 16 numbers, and these are the 16 numbers that you are left with, S1, T3, T7 and these 4 numbers. Okay. So what next? You see the 22, the other end of this 16 member chain, 22 can only be linked to 14, that means this number 2 and 14, so 14, and which in turn can be linked to 2 only, this 2. So you can inspect taking some time, and you will find that these are the only options. So we are adding to this series 22, it ended with 22, and now we are adding 14 and 2. So here we are left with 16 numbers and 2 numbers are used, 2 and 14. So we are now left with 14 numbers. And what are those numbers? S1, T3, T7 and 1 and 15. Okay. Now what next? Again interestingly, this 2 can only be linked with 23, and that is of T7. So now we can couple another triplet with this long series T7. So we get the long series, you write down 3 up to 2, 3 up to 2, and now the triplet 23, 26, 10, right? This triplet 23, 26, 10. So we are getting a bigger chain this time, and 14 was there, now 3 have been used. So we are left with 11 numbers, S1, T3 and 1 and 15. Okay, and so far we can call that this chain is unique. Well, I am writing it again, this long chain of here. The n numbers of this long unique chain are 3 and 10. So 3 and 10. Here these are the end numbers. And we are left with 11 numbers. This and that. But now we can check that 3 can be linked to either 6 of T3 or 1 of this 1 and 15. So 3 can be linked with this 1, 3 plus 1 is 4, or 6, that is 6, 30, 19, T3. So 3 plus 6 gives you 9, a square number. So there are two options, and similarly 10 can be linked to 6 and 15. So not unique, right? So what to do? Again, trial and error with these two options? No. Better for the timing, leave this long chain and focus on the numbers that are left with. That means S1, T3 and 1 and 15. That we can do, we have that liberty. We can leave aside the long chain because we have ended with multi options. Now we can search for unique combination out of these n numbers only. Okay, so let us follow. Here you will see by inspection that 19, this 19 of T3 can only be linked to 17 of S1. So that means this S1 and T3 you can uniquely combine, right? So S1 and T3 can be combined to gives you see here 6, 30, 19, 17, 6, 30, 19, this one is the triplet, and then 17 onwards is coming from this S1, 17, 32, 4, 21, 28 and 8, okay. So we are left with only two numbers, 1 and 15, which are not part of any chain so far, right? And of course we are left with two long chains. One is this one, that means that we have already got and we left here at this stage, and this new one that we have just created, T3 plus S1. So we can say that we have left two numbers and two long chains, right? So what next? So again I have written these two long chain with n number 10 and 3, 6 and 8, and of course the 1 and 15, these two numbers. Now inspection goes on. So we have 4 n numbers as I mentioned, 3, 10, 6 and 8, and a couple of more numbers 1 and 15. But as we have already seen that 3, 6 and 10 are still with multi options, right? So 3, 6 and 3, 1, 3, 6 or 3, 1, this one is possible. Similarly 10, 6, 10, 6 and 10, 15, that is also possible, right? So they are multi options. Then what? Out of all these n numbers, we have troubles with 3, 6, 10, 1, 15. But what about 8? What about 8? We have not inspected so far, and if you inspect, then you will see that 8 has uniquely one option, and that is 1, 8, right? So this 1 and 8. So we can simply take this smaller long chain and add 1 to this, extend this by adding 1. So we can now say that we are left with two long chains, as usual the first one which is not changed in this step, and this longer one where we have added just 1 here, and only 15 is left, okay. So we are very close to our solution. Again I am writing it. So a long chain with 3 and 10, 1 and 6, 4 n numbers and 15. Wow, now it's time for chain closure. So we have to be uniquely able to insert the single number 15. So either you can try with putting 15 between these two numbers, or between 3, 15 and 1. That means either you can attach 15 to 3 or 6 or 1 or 10. So as you see that 15 plus 3 is 18, and 15 plus 6 is 21, and they are not square numbers. So you cannot have that option at your hand that you are putting 15 between these two ends, 3 and 16. So only one option is left, and that is you can try with 15 to put between 10 and 1. That is only logical unique option left with you, right? And again you can declare, wow, it's a perfect triplet, because 1 and 15 is 16, 15 plus 10 is 25, both are square numbers. And not only that, this 15 closes one end of these two chains, right? So 10, 15, 1. So it closes one end of the ring. Still one end is left, and let us see what option is left. The other end is also closed automatically. You won't have to do anything, because you just link 3 and 6 and they are giving a square number 9. 3 plus 6, 9. So 3 plus 6 and their sum is 9, a square. So we get the closure of the other end of these two chains. So we can say that we have finally completed the whole chain, not only the chain but a cyclic chain. We could close the chains, right? So we can finally have the full cycle, right? This. So the longer chain and the smaller chain, only 15 is placed here. Okay, I think you have got it, but preferably you have to go slow while you are seeing or listening to this video. So we get the full cycle, and that's why I demand that it is a unique solution, and you can check with this solution given to start with. Say for example 4, 32, 17, 19, this series, the order of numbers are exactly the same as we have got here in this cycle. Okay, so I think it is established, but if you can find, I'd be happy if you let me know any flaws in my logical steps. You think over that. Until then, goodbye and thank you for listening to the video. Thanks once again.